Surface area. Find the surface area of the surface generating by revolving the curve about the given axis. I have a parametric equation, x equals to 2t, y equals to 2t, and t is between 0 and 3. You can either graph this parametric equation using table values, or you use decimals to graph it. So when you use decimal, don't split this into two lines, like x equals to 2t, y equals to 2t. You are not going to get the right graph. You need to start from a big parentheses, like this, a big parentheses, and then you just type 2t and then comma 3t. Once you do this, decimals recognize that this is a parametric equation, and then they will ask you to input that t goes from one point to another point. This one, as you can see, as t increases, y increases, x and y increases as well, and then you get a straight line, and then from 0 to 3, you get this curve or line, and then we are trying to rotate this about the x-axis. So rotate this about the x-axis, then that will be this. So rotate this about the x-axis, or rotate this about the y-axis. So this one, you can picture that you have one line, right? Or you can hold up your pencil and then try to do this. So hold up your pencil and then grab the tip of one end or the left end, and then just rotate this pencil. Can you picture that? Just grab the pencil, just tilt it, the pencil like this, just like a straight line that is going uphill. Hold on to your pencil. Just grab the left end, and then use your right end, grab the other tip, and then just rotate this about the x-axis. Do you see that this is going to be a surface area? Not a volume, this is a surface area. Another way to picture this is you put a pencil on your table. Just move that left and right. Move that quickly. Do you see that as you move from left to right, you are create something like a surface area? So your pencil is straight, right? So when you move from left to right really, really fast, you can see something that looks like a rectangle. So this rectangle has a surface area. We can rotate about the x-axis. We can rotate the y about the y-axis. All you need to do is what's the difference? The difference is we have this is the arc length, and then we have 2 pi times a parametric equation. So what is g of t? G of t is this. So this is g of t, and then this is f of t. All right, so all you need to do is you take the derivative of each, x and y with respect to t, square that, and then you plug everything into the integral. And then hopefully that when you take the derivative and square, this won't be too hard to integrate. So what I am afraid is this square root. Yeah, this square root may create something that is difficult to integrate. Okay, let's start solving the problem. I have x equals to 2t. Let's move this up. So I have x equals to 2t, and then dx dt, that is equals to 2, and then y is equals to, how about this? I will just say x f of t is x equals to 2t, and then g of t is y equals to 3t, and then dy dt, or g prime of t, that is equals to 3. Okay, nice, there is no variable. We can square that. Dx dt square equals to 4. Dy dt square is equals to 9. Oh, by the way, I already wrote a lot, right? Feel free to just pause the video, write down everything that you need, and then you resume to the video, and then you continue watching. And then they have the square root. Okay, I can do a square root, so we can do a square root of the derivative square plus another derivative square, that is equals to square root of 13. 13, and then t is between 0 and 3. This is like a and b. Okay. All right, and then we rotate about the x-axis. I am going to follow the right color code. So rotate about the x-axis, and then I have s equals to 2 pi, and then integral from 0 to 3, and then g of t, and then times the square root. Okay, the square root, let's follow the square root. I use red. Okay, that is easy to read. and then dt. Okay, I am happy because we only need to integrate the t, right? So the 2 pi stays outside, and then the 3 square root 13. Okay, no need to integrate any of this. And then what is the integral of t? Easy, power rule. So you add 1 to the power, and then you have 1 over the reciprocal of the power. And then such that t goes from 0 to 3. And then the 2 and the 1/2 is cancelled. And then we have 3 root 13, and then pi, and then 3 square minus 0 square. And then 9 times 3 is 27 root 13 pi. What is this represent? This represents surface area. Surface area. So when we about the x-axis, so just like the way I just like what I taught, and then you grab the left end of your pencil, tilted the pencil like what you see on the graph, and then you use your right hand, grab the other tip, and then just rotate about the x-axis, and then you will see some surface area. And then the other one is rotate about the y-axis, and then let's follow that formula. So rotate about y-axis, and then I will do rotate about y-axis, and then the surface area is 2 pi, and then from 0 to 3, and then what's the formula? F of t. F of t is the 2t. Okay, that is the 2t, and then times the square root, and then dt. So that is equals to 2 times 2 is 4, and then you have a root 13, and then you have a pi, and then all you need is you integrate, and then all you need is you integrate the t. The t is 1/2 t square from 0 to 3, and then 4 times 1/2, you have a 2 root 13, and then a pi, 3 to the second power minus 0 to the second power. That is a 2 times 9. 2 times 9 is equals to 18. 18 root 13, and then a pi. So that is your surface area. All right, so that is the surface area. So basically, we just rotate the curve 360 degrees about the x or the y-axis to create some surface area. The simple concept is you just put your pencil on your table, just move left and right really fast, and then you can see there is a rectangle. And then this rectangle has surface area. Okay, so the surface area example is done, and then the next example, I will teach more regarding area of a surface of the evolution. All right, I will see you in the next video.